In this video, we're going to look at another example of trigonometric substitution. Here we have integral 1 over x squared times root of x squared minus 16 integrated with respect to x. So if you have the pattern root of x squared minus a squared, that means variable squared minus constant squared, we make the trigonometric transformation x is equal to a secant theta. Differentiate both sides, we get dx is equal to a sec theta tan theta d theta. We have root of x squared minus 16 in the denominator. That means x is equal to 4 secant theta, because you can think of 16 as 4 squared. Differentiate both sides, we get dx is equal to 4 sec theta tan theta d theta. So we have x squared root of x squared minus 16. Now applying the transformation, x is equal to 4 secant theta, so we get 4 sec theta all squared times root of 4 sec theta all squared minus 16. Let's simplify this. We get 16 secant squared theta, and that inside the radical we get 16 secant squared theta minus 16. If we simplify this further, if we factor out the 16, bring it outside the radical and multiply by the 16 in front, we're going to get 64 secant squared theta root of sec squared theta minus 1. But root of sec squared theta minus 1, that's just going to be root of tan squared theta. Because of the trig identity, tan squared theta is equal to sec squared theta minus 1. So we get 64 sec squared theta root of tan squared theta. That gives us 64 sec squared theta times root of tan squared theta. That will be absolute value of tan theta. But we can reduce that to just tan theta. We can remove the absolute value because of the way that we have restricted the angle theta. So we get 64 secant squared theta tan theta. That is a denominator of the integrand. All right, let's put it all together. So what we have is integral 1 over x squared times root of x squared minus 16 is equal to 4 sec theta tan theta d theta. And this part is actually just dx. And the denominator of the integrand, this part, is going to be x squared root of x squared minus 16. All right, so what we have is, let's simplify this. 4 cancels with 64, giving you 16. And sec theta cancels with sec squared theta, giving us sec theta in the bottom, in the denominator. And tan theta in the denominator cancels with tan theta in the numerator. So when we simplify this, we're going to get 1 over 16 times integral 1 over sec theta d theta. 1 over secant theta is just cosine theta. So we get 1 over 16 integral cos theta d theta. That's 1 over 16. Integral cos theta is sine theta plus c. Now we need to express the answer in terms of x. So what we have is the trig substitution that we're using is x is equal to 4 secant theta. So let's draw a triangle. This will be our reference triangle. And we have a right angle triangle here. Here's theta. Secant theta is going to be, secant is hypotenuse over adjacent. So x over 4 is secant theta. And this is hypotenuse divided by adjacent. So that's hypotenuse is x, adjacent is 4. If you apply Pythagoras, we can solve for the missing side, and that will be root of x squared, hypotenuse squared minus adjacent squared. Minus 4 squared, that's 16. All right, so we know that secant theta is x over 4. That's our trig substitution. Now we can get sine theta. We need sine theta because we want to express everything in terms of x. Sine theta would be opposite over hypotenuse. Looking at our reference triangle, that's going to be root of x squared minus 16 opposite over hypotenuse, which is x. So this reference angle is very important in getting your final answer in terms of x. So let's put that in a circle. So there it is. That's the reference triangle. All right, so what will our answer be? We have 1 over 16 times sine theta, which is root of x squared minus x. I'm sorry, root of x squared minus 16 divided by x plus constant c. So that is the answer to the integral that we have, the answer to this integral. All right, thank you.